Welcome everyone. In this video lecture, we will solve a GATE 2014 question which is based on overall voltage gain calculation in a cascade amplifier. Okay, cascade voltage amplifier. So in this question, it is given a cascade connection of two voltage amplifiers, say A1, A2. Two voltage amplifiers are given, shown in figure. The open loop gain, input resistance and output resistance for the two amplifiers are as below. A1, AB1, the open loop voltage gain 10 for the amplifier A1. Input resistance 10 kilo ohm, output resistance 1 kilo ohm for A1 amplifier. For A2, open loop gain 5, R in 2, that is our 5 kilo ohm input resistance and output resistance 200 ohm. So we have to find the approximate overall voltage gain, that is our V out by V in. Okay, so better to write this one as a V out. So this one is a cascade connection of two amplifiers. So for the just basic that we have to know, suppose two amplifier A1 and A2 is there. Okay, and if we are saying we are giving V in and V output, okay, two are connected in cascade nature. So the V output by V in is nothing but simply multiplication of the gain of amplifier A1, A2. Why? Because if this voltage is say this point is say V1, okay, so A1 can be written as output V1 by V in, okay, and A2 can be written as V out by V1. Okay, we have to find V out by V in. So if we multiply A1 into A2, this is a very simple concept. So this one is the overall gain. Okay, this one is one basic concept. Okay, but in our case, amplifier is given with input impedance, open loop gain, and output impedance. So what we have to do, first we have to know about the amplifier equivalent circuitry. So for A1, the amplifier, I am just making first for the A1, I have to select pencil. For transistor A1, a voltage amplifier will be look like this one is considered as R in plus of minus V in. We are making a voltage amplifier. Okay, equivalent circuit, because in our case the given things are open loop voltage gain, so we can write as AV naught into V in here and one resistance. This one is our R naught. Okay, so this one is the V output. So this one is the, what we can say, the equivalent, that thing we have to know. It is a very simple one. Equivalent circuit of a voltage amplifier. If you know this concept, then the question will be very easy. Equivalent circuit for voltage amplifier. Okay. So here R in the input impedance, AV naught is the open loop gain, and R naught is the output resistance. Okay. So if we can say this one is I naught, I in, no need to mention. So okay. So this one, these two are given the circuitry. So first we have to make the this equivalent circuit. So what I am writing, I am just making the equivalent model for okay, just try to draw the equivalent model. Okay, so this one is our input resistance, so we can write as R is 1, and this one is our A V naught 1 into V in, this one. Okay, and this one is our R naught 1. So this end will be connected here. Okay, and this end we can say it is connected to this point. Okay, and try to connect this one. Okay, so this one is the internal diagram. Okay, now for the transistor, for the amplifier A2, one can also draw R into plus or minus to connect. Okay, this one is our R naught 2, and this should be AV naught 2, and for the time being we are saying this voltage is nothing but simply V1. I am just assuming V1, so it should be AV naught 2 into V1. Okay, and it is connected. So this one is the overall circuitry I am highlighting. Inside this one, this part is very important for this question. Okay, we have made the amplifier equivalent voltage amplifier circuitry inside that block for A1, A2. Now we have to find the value of V output by V in. So which is basically A1 by A2. Okay. So what we have to do in this case, if we considered this portion, this portion, I am just highlighting. If we consider this portion, so V1 can be easily find V1 from this one. We can easily find the V1 from voltage divider rule. Okay, this V1 is nothing but simply this voltage A V naught 1 into V in into the upper, this resistance R into just voltage divider rule divided by R into plus R naught 1. Just I am doing the voltage divider. I am just showing the voltage divider formula. Suppose this one I am saying V1 and some resistance say R into, and this one say R naught 1, and this voltage is some voltage say A V naught 1 into V in. Okay, the same thing I am doing. Okay, so this V1 can be written as, no need to write here, already I have discussed. This V1 is this voltage AV naught 1 into V in R into divided by R naught 1 by R into plus R naught 1. Okay, so this one is our V1. Is it okay? Very simple. So now we can find this one, this value of V1, or we can write this as a, we can write this as a V into input voltage across this amplifier V into. So one can also write this as a V into, depending upon you what you want to write, V into or, okay, because input voltage across this amplifier. So V into is this one A V naught V in. Okay, so now we can find the value of V into or V1, anything you want, what you want to write. So AV naught 1, AV naught 1 is already given 10, okay, into V in is not given, so better to write V in. Then R into is 5 kilo ohm. So 5 into 10 to the power 3 I am writing. Okay. Then R into, that is our 5 plus R naught 1. R naught 1 is 1. So 1 and kilo ohm. So I am writing here 10 to the power 3. I am taking common. So this 10 to the power 3, 10 to the power 3 cancel. 10 into 5, 50. 50 by 6 times of V in. Okay. Now we have to focus on this part. It is very simple. Now we have to focus on this part. Okay. So I am so in this part A V naught to V1, or we can say V in, okay, and V out is there. So what we can directly write, or just I am making the same circuitry. Yeah, this one is RL, R naught 2, and this one is some voltage. Okay, A V naught 2 into V1. Okay, so we have to find this voltage V output. So what we have to do? Just apply what? Voltage divider rule. So V output, this V output equals to A V naught to V1 into RL divided by RL plus R naught 2. Is it okay? Simple voltage divider rule. Voltage divider rule. Or you can directly use simple KVL concept. So, but better to know this type of facts. Okay. So this one will be AB naught 2 equals to this one. So what we have to write? Again, V output AB naught 2. What is the value of AB naught 2? 5. So better to write 5. Okay. V1, for the time being, write V1. We know the value of V1, that is our V into RL. What is the value of RL? 1 kilo ohm. So I am writing 1 into 10 to the power 3. Okay. And RL already 1. So write 1 plus R naught 2. R naught 2, 200. 200 ohm. So better to write this as a ohm. 1K, 1000 ohm plus how much? R into, oh sorry, R naught 2. R naught 2. This one is our R naught 2. 200 ohm. So better to write 200. Okay. So one can write 5 V1 into 10 to the power 3 by 1 0 1 2 double 0. Okay. Or we can write this as a 5v1 into 10 to the power 3. This can be written as 1.2 into 10 to the power 3, 1.2 kilo ohm. We can write, if we remove this decimal, then 10, so 1200. So this and this will be cancel out. So V output will be 5v1 by 1.2. Okay. Now V1 value is already there. V1 value is already there, 50 by 6 P in. So we can write 5 by 1.2 into V1 is 50 by 6 into V in. We are writing this V1 value. Okay. V1. Okay. This one is V1. So what next? Suppose this one 5 5 250, 250, then 7.2. Okay, and V in. So I am writing here V output by V in equals to 250 by 7.2. Okay, we are just going here. Okay, okay. So if we divide 250 by 7.2, it will approximately come to 35. We have already calculated. So our overall gain is our 35. So the correct answer for this question is the approximate overall gain will be 35. Okay. So this is all about this question. So better to know this cascade connection gain, and if voltage amplifier, so we have to know the circuitry of equivalent circuitry of voltage amplifier. It may come as a current amplifier, trans conductance and trans resistance, anything. So you have to know the some basic concept, and by applying simple voltage division rule or voltage divider rule, so we can easily find the approximate overall gain of a two cascaded amplifier. So this is all about this question. So thank you for watching.